It's important to realize that molecular and ionic compounds dissolve differently in water, but first realize that not all compounds do dissolve in water. When an ionic compound is water-soluble, they dissociate into their ions when dissolving, and then these ions are solvated or surrounded and stabilized by the water molecules. When molecular compounds are water-soluble, they remain as intact molecules when dissolving. The only exception to remaining intact molecules for molecular compounds are molecular acids and bases. These, in fact, ionize or form ions even though they began as molecules. What happens when dissolving in water? First, it's important to figure out if the compound is even water-soluble. You can check solubility charts for ionic compounds or learn about molecular polarity for molecular compounds. We'll do that part later. Something important to know about water is it has a molecular dipole. This makes it a polar molecule, and it's capable of stabilizing many ions. So water is a polar substance, and it's capable of interacting strongly with other polar substances. So polar compounds are water-soluble. So first, we've decided if it's water-soluble or not. Once that's done, make a decision about how it will dissolve. So if it is water-soluble, does it dissociate into ions or dissolve as intact molecules? Water-soluble ionic compounds dissociate into their ions, the same ions from which you can consider them having been made. But water-soluble molecular compounds dissolve as intact molecules, except molecular acids and bases. So, ionic substances separate into ions when dissolving, the same ions from which they were made. This is usually called dissociation because the ions already exist. They simply have to separate away from each other and become surrounded by the water molecules. So we can write a kind of general dissociation equation. If you take the formula unit of an ionic compound and put it in water, if it's water-soluble, it will become hydrated, separated ions. So here's a little animation of what it might look like for an ionic compound to dissolve. Down in the bottom, you can see the plus and minus of the solid ionic compound. As the water or whatever solvent molecule, but it would almost have to be water, approach, the ions of the ionic compound begin to separate from each other because they're attracted and hydrated or solvated by the water molecules. Remember, water has a dipole. It has a partial positive and a partial negative side, and this can stabilize those separated ions. Molecular substances that dissolve in water dissolve quite differently. They remain intact molecules. Whole molecules become surrounded and stabilized by the polar water molecules. So we can write a kind of general equation for the dissolving of a water-soluble molecular substance. We write the word molecule because that's how they come, and it simply becomes an intact molecule that's now aqueous, surrounded by water. Here's a sort of animation of a molecular compound dissolving. We have intact molecules on the bottom, and we have intact solvent molecules. Eventually, the solvent molecules will attract and interact with the solute molecules, surrounding them and stabilizing them, but not breaking them into any kind of pieces. Intact molecules can be surrounded and hydrated and stay in solution. So here we can see a molecular substance dissolved as individual intact molecules. The solute and solvent molecules interact, but no covalent bonds within the solute or solvent molecules are broken. Nothing has come apart. Acids are unusual molecular substances. They're unusual because they form ions even though they aren't made of ions to start with. Strong acids form almost 100% ions from their molecules, where weak acids form only a small percent of ions from their molecules, maybe 5 or 6 or 10%. So weak and strong acid molecules ionize different amounts in water solution. This animation gives you some way of seeing the difference between a weak acid, which has its hydrogen pop back on and off and on and off.
An acid is a substance that produces hydrogen ions when dissolved in water. Hydrogen chloride is an example of a common and important acid. When hydrogen chloride gas dissolves in water, it forms hydrochloric acid. Hydrogen chloride is very soluble in water and is completely dissociated. It is therefore a strong electrolyte. Nitric acid is another common strong acid. Upon dissolving in water, nitric acid completely ionizes to form an acidic solution. Like hydrogen chloride, nitric acid is a strong electrolyte. Acetic acid is the major ingredient of vinegar. When acetic acid is added to water, it is not completely ionized. It is therefore termed a weak electrolyte or weak acid.
If a molecular substance ionizes completely, essentially 100% turned into ions, this would be a strong acid. It makes many separated and solvated ions. It's a strong electrolyte. So here could be an indication in pictures of what that looks like. Essentially, all 5 molecules put into the water solution came apart into ions, formed ions. So we get no intact molecules in a strong acid, and 100% of the molecules turned into ions or ionized. Weak acids behave differently than this. If a molecular substance, this would be a weak acid or a weak base, only ionizes partially into ions, many intact molecules remain. There will be mostly molecules present in solution and relatively few ions. So we read an equilibrium arrow, showing that this is going in both directions, that at any given moment we have intact molecules and ions existing in the same solution. Actually, this time only 2 of the molecules put in at any given moment have turned into ions. The others remain intact molecules. So at any moment a sample from this solution contains intact molecular acids and the ions from acids. So now let's try to actually produce equations which represent dissolving. These are all ionic compounds, and ionic compounds will always dissociate into their ions. In each case, the ions that they produce will be the same ions from which they were formed. We also are paying some attention to the number of ions that we'll get, because later we'll study something called colligative properties, which depend a great deal on the number of dissolved particles and not so much on their identity. Let's look at equations representing dissolving in water for molecular compounds. Molecular compounds dissolve as intact molecules, if they dissolve at all. But remember, acids ionize into newly formed ions. So the top 2 on this slide are acids. And so we start with an intact molecular compound, but we end up with ions. Note that one is a strong acid and one is a weak acid. The bottom 2 compounds are molecular compounds, polar molecular compounds. Both of them will dissolve in water, but when they dissolve as intact molecules.